this one's a little taller, okay, but the bottom is about the same area as the first one. The difference is there's quite a few differences. Let me show you what the oil configuration inside this looks like. So this is what the oil looks like. This is the shape that the oil takes inside this form. Alright, so I'm going to show you the shape of the oil inside this form. It looks like this. Now you can see that there's quite a bit of difference. This is based on the idea that you will avoid the problems that you had with this one. This one had problems because all of the oil was coming out of the top of a pyramid. And all the oil was being pressed up into here through pressure. And also they found out that there's a lot of gases coming up with the oil, which causes a kind of they call it hydrates. It's a forming of ice crystals around the opening, so that it kind of froze closed, and then the air, the gases and stuff are collected here, and the oil also kept coming up, so it started to float. Okay, so this clogged up. And this is because of this freezing point. Alright, in this design, the oil stays basically at the bottom, but it has three risers that come up. So as the oil goes up slowly, because it's such a big volume, the gases have a chance to go up, and of course they will come up. The gases are represented in this one in the white area, and so you're separating the oil from the gases. And of course at the top here you have relief valves. These relief valves allow the escape of the gases, also allows it to descend. This also had relief valves also. But now you have three of them. So if it starts to float on one side here, okay, then you release this one and it will settle back down. But the main idea is that it's separating the oil from the gases so that you don't have this freezing problem, because this has the gas and oil together coming out of the same spout. The oil is coming out of the center of this form. Not from the top, but from the center, way down in the bottom. So to show you basically where that's happening, I will show you this. I will take this, I will put this back in, the oil back into its space, and I'll remove and show you what the shape looks like. This is what the shape looks like. In other words, what's inside this. And what's inside this is this form. That's the geometric form, and the reason that I went from circular forms or cones is because the geometry is very efficient, but also it's cheap to make. This would be very difficult to produce, so it would cost more money. This could be made very fast. Everything is flat sheets. And a crew of contractors and so forth could put this together in 1 month. And you say, well, that's too long. It's not, because they got 3 months before they even have a solution of these two ways of drilling to relieve the pressure from each side of the existing leak. And if they can't cap it, this should still be started tomorrow, because nothing may work that they are trying now. But this is a chance that when it is done, that it will work. And it could be reused if it does. In many situations that may happen, even along California coast, this may happen. So you'll notice that the entrance for the oil is down here in the middle, and it has this sort of a funnel shape. That funnel shape is like this. It doesn't have any edges where the ice can gather. And of course inside is a coil that heats up. And this is controlled from the top by electric cables that come in from the top where the ship is. And these will be not only in the center, but they'll also be here too if there is any ice formation. Now this basic shape here that makes this is a pyramid shape. Here's what it looks like. This is this shape, so you know where this is coming from. The shape inside is coming from this shape. And this shape, of course, sits right into here and snugs right up against there. And it divides it all into 3 vents. Now, of course, where does this form come from? It's also based on this. And how I did this is I just did a reversal. Instead of having it sucked at the top, okay, it's like taking a glass of water or a milkshake. You know that you don't suck the milkshake from the top. You take it down inside there and suck. That's the principle of this, what I saw. So what I did is I just reversed this down in here like this. Okay, I went like this. And then I took this part off of this original comb now, and I turned it upside down, and I filled this with cement. So I filled this entire cup with cement, and then I put it back in. That made this very stable. And remember that this form is filled with cement, and it's right in the middle, which puts all the weight right straight down onto where the leak is. It's also have this cement casing that goes all the way around it. It's very thick and weighs as much as this. That's on the outside, and that's what's on the outside here. Okay, so the arrangement, okay, is converted to geometry. In other words, this whole structure is based on a pyramid. So if you take this particular shape, this one, you'll see that it comes from the same shape. To show you that it does come from the cone. There's the top of the cone, or the side of the cone, and here's the top. And of course, originally, that was this one, which was very up at the top. Of course, this shape is in here now, like this, but turned upside down. I reversed this, turned it upside down, so all the weight would be in the center. So this would have a hard time getting and floating up. So, let's see. This, I don't feel, would be very hard to construct. If a crew got together, I think that it should be constructed as soon as possible, either by BSP, or it should be done by Japan, or America, or Australia, whatever. Somebody should start making this, because I know from all the studies that I see that there's a very good chance this will work. And there won't be any ice crystals causing any of this to happen. And the suction is at the bottom, and it's being warm, so there's no ice crystals forming. And this abandoned one here, I tell you what you could do is you could bring it back up if possible. You could cut it all the way around, turn it upside down, and now you could fill that with concrete, and it would serve the same function as this one. And also be very stable. And then the suction here, which would be cone shape, would be in the bottom. Okay, you'd have 4 vents, and you'd have the same principle as going on here. This is much more stable because it's based on 3. This is my idea. I think it would be relatively fast to construct. I think you could do it within a month. And you still have 2 months before this drilling operation takes care of it. If it works in 3 months, at least you'd be able to tap this for 2 months until this pressure was relieved, if these drillings work. That's my idea. There's many thousands of ideas out there, but this is one of them. So thank you. Thank you for listening.